that has captured our imagination for centuries is revealing more than we ever expected. With each new image sent from orbiters and rovers, we discover more secrets buried beneath its rusty surface. Dried up stream beds, strange cloud formations, and faint remnants of a time when Mars had lakes and seas. They are puzzle pieces pointing to a past when water flowed freely across the Martian landscape. From the search for microbial life to the possibility of human colonization, Mars remains the most likely candidate for the next frontier. In turn, the colossal Olympus Mons volcano, dormant for millions of years, may not be as silent as we previously thought. Could the red planet still be geologically active? And if so, what does this mean for our future explorations? Will Mars one day become our home? The red planet awaits, so let's get started. Allowing us to understand both its ancient past and its current state. Research shows that Mars, once warm and wet, had extensive bodies of water. Today, however, it presents a very different landscape, cold and desolate. This transformation raises crucial questions. Where did all the water go? According to a joint study by Hubble Space Telescope and NASA's Mars Atmosphere and Volatile Evolution, Mars is losing water at an alarming rate, especially as it approaches the Sun. The study shows that seasonal variations significantly affect the rate of these losses. At perihelion, the point of the orbit closest to the Sun, the planet experiences increased atmospheric heating. The spacecraft has photographed countless Martian clouds and storms that provide the most detailed view of the planet's atmospheric phenomena, which are at once alien and so familiar. This summer, scientists at the German Aerospace Center compiled images taken by a camera aboard the spacecraft into Cloud Atlas, which provides an immersive virtual tour of the red planet's clouds. Unlike Earth, where clouds are composed mostly of water vapor, Martian clouds are composed mostly of carbon dioxide. The planet's atmosphere is so rarefied that any moisture present is a layer thinner than a strand of hair. However, despite the lack of water, these clouds form in surprising ways. One of the most striking examples is the Mons elongated cloud, abbreviated AMEC, a massive formation that appears each spring near the southernmost of the planet's giant volcanoes. This elongated water ice cloud is formed when winds rising along the slopes of Mons cool rapidly at high altitude and cause moisture to condense. What makes AMEC so unusual is its sheer scale. It can stretch 1,100 miles long and move at speeds up to 370 miles per hour. Although the cloud appears volcanic because of its location, scientists have ruled out the possibility of volcanic activity, attributing its formation to a complex interaction between wind and the Martian landscape. The appearance of Martian clouds is not limited to this region alone. The planet's atmosphere supports a range of cloud formations, including cloud streets, linear rows of clouds that resemble cumulus clouds on Earth. They're often observed in lowlands near the poles, such as Vastitas Borealis, and near volcanic regions such as Olympus Mons and Orissa Mons. Although they may resemble terrestrial clouds in shape, the conditions under which they form are quite different.